Assalamualaikum warahmatullahi wabarakatuh and a very good afternoon to Midmain. I am Farhan bin Zana Abidin. Today I will present to you about my research project about physical, chemical and electrochemical characteristic studies of electric arc furnace light EAFS. Before I proceed to introduction, I would like to highlight that this research was supervised by Madam Hawawiyah Imam Ma'aruf as my supervisor. What is EAFS? EAFS is an abbreviation for electric arc furnace slag, which is a byproduct from smelting metal process. How it was produced? The working principle basically consists of obtaining desirable products by melting the scrap metal and its chemical adjustable. The equipment used for smelting process is electric arc furnace. EAFS are produced when the steel have been molten. Literally, EAFS is physically stony, cohesive, slightly porous, and tough. It is commonly used as aggregate for concrete, road bases, and asphalt paving. Move on to problem statements. There are some complications that have to be dealt when performing this research project. DEFS can causing environmental problems due to its heavy metal content. Besides that, complication when using acid and alkaline as leaching reagents due to their difficulties in dissolving complex compound. Then, EAFS have poor grind ability due to presence of metal oxides which form a dense structures such as iron oxide. Therefore, to tackle these problems, some objectives have been met. Firstly, to characterize EAFS for its physical, chemical properties. Secondly, to determine the electrochemical properties of EAFS from leaching process and applying cyclic voltammetric concept. For physical and chemical characterization, the study focused on by review some previous studies by another researchers. Meanwhile, for electrochemical characterization, two experiments were conducted. Firstly, by conducting leaching process by utilizing three different reagents such as hydrochloric acid, sodium hydroxide, and sodium chloride in order to determine ion concentration recovery. Second experiment was conducting electrochemical study by applying cyclic voltammetry concept using potential stat to determine species reaction in EFS solution. For methodology, there are three processes were conducted. Firstly, preparation of raw EFS. The sample was collected from smelting factory at Pulau Pinang in the shape like sand. The EFS was grinded and sieved to obtain the size around 75 to 150 micron. The sample was stood to undergo leaching process. The step was by taking 10 gram of EFS sample, then put into 100 milliliter of 5 molar of hydrochloric acid. Then heat up at constant temperature at 80 Celsius and constant heating time, which is 3 hours. The steps were repeated for sodium chloride and sodium hydroxide. After that, iron-rich solution which from the leaching process were utilized for electroactive species test. This cyclic voltammetry study was conducted by using potential stat and screen-printed carbon electrode like figure that have been shown. For results, these are three results been obtained from leaching process. These results come from three different reagents which are from the left, hydrochloric acid, sodium hydroxide, and sodium chloride. Below is the table for output response of leaching process. As we can see, hydrochloric hydrochloric acid recovered the most iron from the sample, which concentration about 28 million milligram per liter, followed by sodium hydroxide and sodium chloride, which averaged 16.33 and 0.45 milligram per liter respectively. As you can see, for figure at the left side shows the greenish color of metal-rich solution in 5 molar of hydrochloric acid. The solution was viscous. It is because height of hydrochloric acid concentration affect the dissolution of Eafs. That's why the iron concentration in 5 molar of hydrochloric acid was high. For cyclic voltammetry study, 6 graphs were plotted which divided into 2 different analyses. Firstly, on the left one are graphs for comparison of metal-rich solution in 5 molar of hydrochloric acid, sodium hydroxide, and sodium chloride with its background, which is 1 molar of hydrochloric acid, sodium hydroxide, and sodium chloride. The top left is the comparison of metal-rich solution in 5 molar of hydrochloric acid with its background. Both plots were the first cycle of the cyclic voltammetry. It can be seen there are oxidation and reduction happen for metal-rich solution in 5 molar of hydrochloric acid since there are 2 peaks formed at the upper and lower cycle. When compared to 1 molar hydrochloric solution, it can be said that the oxidation happened in metal-rich solution. Therefore, it proved that there are chemical species in EAFs. For the middle one is the comparison of metal-rich solution in 5 molar of sodium hydroxide with its background. It can be seen upper peak which indicates oxidation reaction barely happen, which can be assumed there are no oxidation reaction between metal-rich solution species in 5 molar of sodium hydroxide. For reduction reaction, graph 1 molar of sodium hydroxide shows a large lower peak form which indicate 5 molar of sodium hydroxide in metal-rich solution be reduced instead of metal-rich species. In contrast, compared to hydrochloric acid and sodium hydroxide, for metal-rich solution in 5 molar of sodium chloride and its background have identical cyclic voltammogram pattern as shown in graph below left. After 0.5 volt, there are no peak was observed, which can be deduced there are no oxidation happen within these two solutions. The reduction peak happened for both solutions, which proved that reduction process solely come from the background. Move on to the right side graph. This tree graph indicates metal-rich solution reaction in 5 molar of hydrochloric acid, sodium hydroxide, and sodium chloride without comparing with its background. We take the first graph, which is graph for metal-rich solution in 5 molar of hydrochloric acid. This graph compares the reaction happen for three cycle of reaction. We can see it shows an electrochemically reversible system as there are 3 peaks formed at cathodic and anodic current. There was a significant, as we can see, there was significant increase in reduction peak at cathodic current throughout the cycle, which means there are reduction happen between metal-rich species. Move on to the middle one. This graph is for metal-rich solution in 5 molar of sodium hydroxide. As we can see, the highest reduction reaction occurs at first cycle at anodic peak. After the first cycle ends, the peak decreasing significantly for second and third cycle indicates all the species have been reduced along sodium hydroxide at first cycle. For the last graph, which is the metal-rich solution in 5 molar of sodium chloride, it's showing oxidation and reduction happen. But oxidation only occur at second and third cycle instead of first cycle. This case may happen if oxidation at the electrode, which is carbon component, been oxidized instead of metal-rich species. On the other hand, reduction happen at first cycle, which indicates some Eafs species and sodium chloride have been reduced. Conclusion: based on the leaching and cyclic voltammetry study, I can deduce that acid is the best solvent to recover iron from Eafs than alkaline and neutral. That's all from me. Thank you. Assalamualaikum.